Alright, this lesson is going to be over number types. Our objective for this lesson is to understand the number types, to classify numbers into their types. The vocabulary for this lesson is as follows. Real numbers, all rational and irrational numbers. Irrational numbers, numbers that can't be written as a ratio. Another name for ratio, a fraction. Radical expression, solution that contains the square root symbol. And rational numbers, numbers that can be written as a ratio or a fraction. Let's start with the real numbers. We're going to represent it with this box. I've split the box into two halves, or into two parts, really. The irrational side and the rational side. The rational side is bigger because we're going to divide the rational numbers into other subgroups of numbers. The first of those subgroups is what we started with when we were in kindergarten and first grade. The counting numbers. We count with these. 1, 2, 3, and so on. After the counting numbers, we progressed a little from there. And we created whole numbers. Whole numbers include the counting numbers, but also add in with it. And what we add in to the counting numbers is 0. So the whole numbers are 0 plus all the counting numbers, 1, 2, 3, and so on. After whole numbers, we went a little bit further. And we went on to something called integers. Now, integers include the whole numbers. They include the counting numbers, and then add with it the negative versions of the counting numbers. So -1, -2, -3, and so on. Then we actually get to the big group called rational numbers. Rational numbers can be written as a ratio. Another name for a ratio is a fraction. So this is where we start adding in fractions. Fractions can also be turned into decimals, so many decimals are included in the rational numbers. Some examples would be 5.7, 1/2, -8.5, -2 1/3. These are all numbers that can be expressed as fractions, along with all our other subgroups. Irrational numbers are numbers that cannot be represented as a fraction. Some examples of those are the symbol pi represents a number that never ends and never repeats. Therefore, it can't be written as a fraction. Square roots that don't come out perfect, such as square root of 3, typically are considered irrational because, again, they will never end, they will never repeat, they cannot be written as fractions. Now let's do some example problems. For 8, if we're looking at what type of number that is, well, we can count to 8. We do it all the time if we're counting people. So this would be considered a counting number. Because it's a counting number, it's also a whole number, it's also an integer, it's also a rational number, which means it's also real. Square root of 2, if we get our calculator out, type in square root of 2, we get a number that goes on forever, never repeats. That's considered irrational. 3.5, it's a decimal, it ends, therefore it can be turned into a fraction. That's a rational number. Negative 11, well, it's not a counting number. We don't usually count by negatives. It's not a whole number because it's not 0 with the countings, but it's a negative version of a counting number, meaning it's an integer. 3 plus the square root of 3. Because the square root of 3 is in this problem, square root of 3, if we type it into a calculator, we don't actually get a nice pretty answer. We get a number that goes on forever, never repeats. So this combined together is irrational. The negative square root of 16. This one's a tricky one. The square root of 16 is actually a perfect 4. Because it's negative, we're looking at negative 4, meaning this is an integer. Negative 8 over 3, well, that's a fraction. Whether it's negative or positive doesn't mean much because they're all parts of rational numbers. Then you've got 105. Well, if we started counting from 1, at some point we're going to get to 105. So that is actually considered a counting number. If there's any part of this video that didn't make sense or you just didn't get it, please pause, go back, and watch again. Thank you.